Given VGS is the gate source voltage, VDS is the drain source voltage, and VTH is the threshold voltage of an enhancement type NMOS transistor. The condition for transistor to be biased in saturation are, okay, see, first thing is they are asking what is the condition for the transistor to be biased in saturation, and one thing is when the inversion layer will create. Okay, see the one thing, for the creating an inversion layer, for creating inversion layer in n channel MOSFET, inversion layer in n channel MOSFET, for creating inversion layer in n channel MOSFET, we required VGS should be greater than equals to VTH. VGS should be greater than, at least it should be greater than equals to VTH. It is required. Now, second is to operate the n channel MOSFET, to operate the n channel MOSFET in saturation region, for operating n channel MOSFET in saturation region, the VDS should be greater than equals to VGS minus VT whole square. VGS minus VTH, okay, should be greater than VDS minus VTH. Okay, it should be. Then only the MOSFET will operate in a saturation region. Okay, therefore the option D will be the right answer. Option D will be the right answer. Okay. A current controlled current source has an input impedance of 10 ohm and output impedance of 100 kilo ohm. When this current controlled current source is used in a negative feedback closed loop with a loop gain of 9, the closed loop output impedance is, see, it is given that current control current source, okay, means we can say that in input it is a current control and output is it's a current source. Means say, can I say, if this is a current control current source, means there must be a input, at the input there must be a current, and we know that input we are always doing the mixing, and output it indicates also see it's a load, and also at the output there is a current source. Means see, in output it's a current source, means in output we are always doing a sampling, and sampling means measuring, means we will do in this way, and we know that the current is always measured in series. Because the ammeter is connected in series. This will be the IL. Okay. Now see, current is always adding in a parallel. Then only, means because we know that in input there is a mixing, mixer, and we know that the current is mixed, means add or subtract in parallel or in shunt, means this will be the connection. And I told you the lectures, it's a feedback network, and it is given that this Ri, it's Ri equals to 10 ohm, and it is Ro equals to 100 kilo ohm. And I told you, see, in input there is a mixer and there is a shunt mixer, and we know that in a shunt the net resistance will decrease, because see, there is a shunt connection, parallel connection, and we know that in a parallel connection the net input resistance will decrease. And in see, at output there is a series connection, because this is a sampling and this is a current sampling. This is basically a current sampling. Okay, and see, this is a series connection, and in series the net resistance is increases. Therefore, the output resistance RO will be increased. RO of the feedback network will be increased. By the RO, it will increase by 1 plus A beta. Okay, definitely in feedback amplifier anything will be increased or decreased by 1 plus A beta. Now see, it is given in the question the loop gain. Loop gain means we know that. Loop gain means A beta, and it is given that 9. Therefore, see, it's a 100K, 1 plus 9 is that will be 10, it's a 1000K. It's a 1000K, I think it's a 1000K kilo ohm. Therefore, the option D will be the right answer. Option D will be the right answer. The enhancement type MOSFET in the circuit below operates according to the square law. Mu n COX W by L equals to 100 microampere per volt square. The threshold voltage Vt is 500 millivolt. Ignore the channel length modulation. The output voltage Vout is. See, it's a very simple. This is NMOS given. This is a Vout. Okay. This is a 5 microampere. This is VDD equals to 2 volt. Now see, in this question it is given that here the W by L is also given. W by L equals to 10 micrometer by 1 micrometer. 10 micrometer by 1 micrometer. Now see, it is given in the question mu n COX is 100 microampere per volt square. Okay, threshold voltage Vt is 500 millivolt, and it is given that the channel length modulation is 0. Now see, we know that the MOSFET is working as an amplifier when it is in a saturation region. Okay, first we'll calculate it and then we'll also check it, means it is correct or not. Now see, it is known that in a saturation region, we know that ID equals to half mu n COX W by L VGS minus VT whole square. Okay, now see, we have to calculate the Vout. See, this is Vout and this is VGS. We know that, see, this is directly connected here, means Vout will be the VGS, and our aim is to calculate to VGS. See, ID is given 5 microampere. ID is given 5 into 10 raised to power minus 6. It's a 1 by 2, and mu n is 100 microampere per volt square, means 10 raised to power minus 6. W by L is 10 by 1. Micro means it will get cancelled. Okay, micro will get cancelled. It will be a 10 by 1. VGS minus VT is given 0.500 millivolt, means 0.5 volt square. From here we can say that VGS minus 0.5 square equals to 2 into 5 into 10 raised to power minus 6 divided by 1000 into 10 raised to power minus 6. Therefore, the VGS should be equals to 0.6 volt. 0.6 volt. If you will solve this, it will come VGS equals to 0.5 volt, and we know that Vout equals to VGS equals to 0.6 volt, or we can say that 600 millivolt. Okay, this is the answer. Now see, if you want to check the given transistor is operating in a saturation region or not, see, you calculate the VDS and we can check it. Okay, or second thing, the transistor, the MOS is operating, follow the squaring law. Now in this case the MOS is following the square law, means this is also correct. Next, In the circuit shown below, the operation amplifier is ideal. If V1 equals to 10 millivolt and V2 equals to 50 millivolt, the output voltage is, okay, you'll see the output voltage. See, this numerical is very easy, very simple numerical. It's a VO. Okay, see, here it is 10K, here it is 100K, here it is 10K. Okay, this is V2, and here it's a 10K. Now here it is 100K, and here it is V1. See, we can directly solve this numerical. First of all, it is given that V1 equals to 10 millivolt. V1 is 10 millivolt and V2 is 50 millivolt. Now see, when you will consider the V1, when we will consider the V1, the op-amp operates in a inverting mode, or op-amp acts as a, when we will consider V1, op-amp acts as an inverting amplifier. Inverting amplifier. Second, inverting amplifier means, let's say it's a VO1. VO1 is minus RF by R into VI, or it will be V1. Means see, minus RF is minus 100, sorry, 100 here, K by 10K, KK gets cancelled into 10 millivolt. Means it will be a, see, this K gets cancelled, this will get cancelled, means it will be a minus 100 millivolt. It's a VO1. Now consider V2. Then the op-amp acts as an non-inverting amplifier. Non-inverting amplifier. Op-amp acts as a non-inverting amplifier. Okay, we know that in this case VO2 will be 1 plus RF by R into V plus. What is V plus? This is V plus. And now see, 1 plus 100 by 10, V plus means it's a V2. V2 is, what will be my V plus? V plus means V2 into 100 upon 100 plus 10. Means V2 is 50 millivolt into 100 K divided by 10 plus 100, 10K plus 100K. KK gets cancelled. This K, this K, this K, here K and K, this K will cancel, and it will become, see, this 0 will cancel, it will become 11, because 1 plus 10, now 1 plus 10. Now see here, it's a 50 double 0 okay, divided by 110. Now see, this 0 will get cancelled, this 11 will get cancelled, this will become 500 millivolt. 500 millivolt. And after this is a VO2. Now we know that VO equals to, by using superposition theorem, VO1 plus VO2. VO1 is minus 100 and VO2 is plus 500. Means it's a 400 millivolt. 400 millivolt. This is answer. 400 millivolt. You can solve it very easily.